Alrighty. So yeah, I've graded about half, maybe a little over half the midterms. Really great job so far. All the grades are between A's and C's, with the majority actually being A's. So really, really pleased to see the work there. Like I mentioned in the last class, I'm trying to give good feedback, especially on that last problem of where you missed points and why. Please, 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 if you still don't understand our markdown files, or if you didn't even upload an R markdown file, because I know a couple of you uploaded R files, R script files, please make sure to schedule some time or schedule some time with Brad or me or Kristen as well. I know she has her office hours too. So, please get with one of us, because like we mentioned last class, we're going to continue building off of that. So you are going to have additional assignments that are going to require you to upload our markdown files plus the knitted Word or HTML file as a result of that. So we want to make sure everyone understands that, because I'm trying to be as lenient as possible. I was on assignment 3 and still a little bit on the midterm, but this next time that's an assignment submission and requirement, I'm not going to be able to be as lenient on the grading. So please just be careful about that. And then once I get through, I expect to have all the grades done and posted before our class on Friday. So I'll take a few minutes to just go over any common things that I've seen at that point. But we'll go ahead and wrap up regression today with Brad.
And just to give you guys a piece of advice that you didn't ask for, because that's what professors do at all points, right? Just a good philosophy for any class: make life as easy as possible on the person grading your assignment. Like, there is a study out there that shows happy graders give higher grades. So like, if you can do something to format it that legitimately just requires an email saying, hey, can you guys help me with that? You should. Okay. And it's like I told you guys before, if knitting is the problem, like if getting the file to look right is the problem and everything else is in the file is right, send us that file and say, can you help me please with this part? And we'll figure out a time to do it. Again, as long as that timestamp's on there, I'm good with it. Okay. If it's just about getting a file right, I'm good to help. Catherine's good to help. Kristen's good to help. But please, 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 please ask for help. And again, I will drive this point home. Do not ask for help at 11:59 when the due date is midnight. Okay. I get if something broke and you're frantically like, hey, it worked 5 minutes ago. That's fine. Send that email. We'll get it cleaned up. But that should not be the first time you press knit. Okay. And we'll talk about that more today as we go to. All right. Any questions before we get rolling? I love the analysis of my World Series predictions in the chat right now. That's always good. I would not recommend following those predictions for anything. As you guys will figure out, I'm not that great at prediction most of the time, so it really works. And that's actually what we're going to talk about today. So when we kind of moved off of, got a little cold going here, guys. When we moved off last time, and let me go ahead and share my screen so you guys can see what's going on here, because that's always useful, right? I'm gonna hit share and we're just gonna go, okay? So when we were talking about last time, what we talked about was actually using this stuff in practice, and how I've spent, probably a week and a half now talking to you guys about how to do something that takes you 15 minutes in practice, right? And that 15 minutes is basically going to give you a single line off a slide. And that's going to give you one thing you can hold on to. And all I will tell you there is, welcome to the world of being an analyst. Welcome to doing data analysis for a living. There's a reason I tell you all this is a blue collar job in a white collar world. You get to sit at a computer, you get to work at a desk, you get to, not have to dig ditches. But what you're going to do is put a lot of time and effort into things that are going to feel real small at first. But how you build that culture comes down to how you present this information, okay? So what I want to do today is walk you guys through some stuff and walk you through just some examples. But really what we're trying to motivate today is to get into this idea of multiple linear regression. So simple linear regression means one predictor, and that's what we're going to finish off today. That's going to be end of section 5, right, Catherine? 5. And then we're going to start section 6, which is more complex and advanced regression.
Right.
Okay. So, and the reason we want to do that is because I want you guys to have some reps of just simple linear regression. Okay. Just this idea of one predictor. How do I interpret? Because I really want to stress that interpretation aspect of this thing is really, 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 really important. Okay. And if I can't say really more than that, I'm in trouble. So as we go through today, what I want you thinking about is, why do we need more information as a predictor? Why do we need more inputs? Okay. And I'm going to motivate it a couple different ways. All right. I'm going to motivate it mathematically. I'm also going to motivate it from like a concept standpoint. All right. So as we go through this, just kind of keep in mind a couple of the different points we're starting to converge to here. Okay. So the next example I want to look at, a package called ISLR. And ISLR is one of my favorite packages because it's got a bunch of data sets in it and all of them pretty cool and have some interesting trends. So if you want to go download that package for me, just go to package, go to install, and just type in ISLR. What ISLR stands for is Introduction to Statistical Learning R package. It's a book. It's a great book. It's one of my favorite books. It's a free book. If you Google Introduction to Statistical Learning in R, which I think we sent out on the updated syllabus, you'll find this book. Now, there is a second edition that is not currently free. You guys will figure out about me. I'm cheap. I don't like you guys paying for stuff you don't have to pay for. So guess what? That second edition is really cool. If I need something out of that second edition for some point with y'all, I'll buy it and I'll type up notes on it. Okay. If you guys want to buy it, you're more than welcome to. I'm not requiring it, but there is a free book out there that I think you should go get, look at, and it may help you at some point. It will be required to download if you hang out with me in 451. Okay. Chris, what's up?
Do we download this regression example RMD file on eCampus and then install the package, or we can just start from a normal RMD file on our system?
You can start from a normal RMD file on your system. Anytime you want to download a package, you don't have to do it in the RMD, right? You can just download it. It lives on your computer.
Okay.
That's
Brad,
one of the, yeah.
I think because Nishal also asked a similar question. I think they're looking for this regression examples RMD that you have. So this is the one that Brad started at the end of last week or Monday's lecture, where he just started it from scratch and hand coded it, and you guys could kind of follow along. So
and this is where I want you more paying attention than coding yourself for right now. That's the reason I've held it. Okay. I don't do this to y'all often, and I won't probably do it again. But when we're talking about this, because I want to stress interpretation and not code right now, because the code is really simple. And that's what I want to do before we jump into the other piece today, because the process is really simple. I want you focusing on what I'm doing. This is being recorded. You can go back and watch it. But I want to hold the RMD file for a minute. So we're talking about concept and code simultaneously. Y'all good with that?
Yep.
I'm sorry if it annoys you. I'm sorry if you wish it was the other way, but trust the method to my madness right now, please. That's the only thing I'll ever ask you guys. All right. There is a method to my madness.
So one
Now,
last question.
Yeah. What's up?
Sorry to interrupt.
No, you're good.
So again, it's okay to start with scratch and create our own R Markdown file, right?
Absolutely. 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 I'll never penalize you guys for trying something. That's what you'll figure out about me. All right. I want you guys to try stuff. If you break it, ask us why you broke it. All right. If we're not working on it in class, stay after, ask us how it broke, ask it why it broke, share your screen, schedule some time with us, do that. I'm always 100% fan of you guys trying stuff. All right. Now, what I'm doing today, I want to walk you through my process. I want to walk you through what I think about and how I do this. All right. So when I'm setting this up, we're going to explore the credit data in the ISLR package. Okay. And just to give you some ideas of what's going on in this data after you've done it, this data is simulated, okay? Because most data is going to be simulated when we're talking about people's credit scores, right? Like nobody's just going to post that information someplace. So it's a simulated data set containing information on 10,000 customers. The aim here is to predict which customers will default on their credit card debt. That would be the aim for the book and for the data set itself. This ain't that book. That's something we'll cover in 451. What I want to do right now is start understanding some of the basic relationships that go on in this data. Okay. Now, the data has an ID, which is an indication number, right? Identification number, not indication number. Guys, I'm out of it a little bit. Okay. Income in $10,000s of dollars. Limit, that's their credit limit. Rating, a credit rating score. Number of credit cards, age in years, education, gender, a factor with levels male and female. Student, a factor with no and yes. Married, a factor with no and yes. Ethnicity, African American, Asian, and Caucasian. Balance. All right. Now, what I want to do first, just so you guys can get a feel, is walk you through my process. So what I did to create this was I just created a new chunk. How do I create a new chunk? 3 tick marks are 3 tick marks, okay? And then what I did, I'm just going to delete that, is I said, look, I'm going to do exploratory data analysis, all right? To me, exploratory data analysis are just some of the basics. So the first thing I do is I load up the relevant libraries, okay? Remember, I don't have to install them. I've already installed ISLR. I don't need to install it in the RMD, right? You don't have to download Microsoft Word every time you use Microsoft Word, right? You just double click it and it loads. Remember, library is us double clicking something that's loaded, all right? You can always use the GUI to do the install. The next thing I do is I start looking at the head of the data. What's the head of the data? So I'm going to load up my library and I'm going to look at the head of the data. What's the head of the data? It's the first 6 rows, right? So to me, this gives me a feel for what I'm actually looking at. I've got this ID number, which just looks like 1 to 10,000, right? I've got income. All right, that's income in tens of thousands. Here's the credit limit. Here's the credit rating. Man, those 2 things probably should be related, right? Here's cards. Here's age. Here's education. Here's gender. Here's student. Here's married, ethnicity, and balance. So here's what we're going to do today with this data set. We're going to use it 2 ways. The first thing I want to know, and the first thing I want to see, is I want to look at the relationship between credit limit and credit rating. Chris, what's up?
I'm sorry, I'm bothering you again and again.
You're not bothering me. What's up?
For some reason, I try to insert the command for head credit and it won't give me a response and throw an error to me.
It throws an error?
Yeah.
Copy and paste that error in the chat and I'll have Catherine look at it for you, okay?
It says it just says the object credit is not found.
You need to load the library then. Make sure you install and load the library.
Okay, I'll try that again and just text Catherine.
Okay.
Thank
Awesome.
you.
Appreciate it, guys. All right. So what I want to do here first is I want to look at the relationship between limit and rating. Okay. By looking at the relationship between limit and rating, what we're doing is we're seeing what information is actually in your credit limit that's already not contained in your credit rating, right? Because think about it. How does somebody set your credit limit? They look at your credit rating, they look at your income, and they probably set it. You guys agree with that? I mean, that's a very simplified version of how credit works, right? But I also want to check later how it relates to balance, and we'll start looking at that too. So the first thing I'm going to do, now that I've taken a look at these things, is I'm actually going to add another line in here, summary credit. Now, remember what summary credit's going to do. It's going to talk to me about the summary of the data. So remember, I'm looking at limit and rating right now. So the minimum credit limit is $855. All right. Yeah. $855. The minimum credit rating is 93. The maximum is 13,913 with a maximum rating of 982. Okay. So I'm interested in these 2 variables. So I'm just going to limit my analysis to that. And what I'm going to do is I'm going to look at the correlation between credit limit and credit rating. And what it tells me is the correlation is 0.9968. That means by just understanding your credit rating, I can understand 99.6%, or excuse me, no, the correlation between the 2. I'm sorry, I was interpreting it as R squared, which we'll talk about here in a second. The correlation is 0.9968. What that means to me is it's really strong correlation. It's really positive correlation. You guys agree with that? Positive correlation means what? It means as rating goes up, limit goes up. Yeah, that makes sense, right? It's really close to 1. The easiest way to look at that is the plot. So let's ask 2 questions here. Do you guys think correlation is a good assessment of the relationship between these 2 things? Correlation assesses what? Direction and strength of linear trends, right? Direction and strength of linear trends. Is that a straight line? Does a straight line go through that data? 100% honesty here. You will never see a better data set for a straight line to go through. Okay. Now, is it going to explain everything? No. Right off the bat, we can go ahead and understand what percentage of the credit limit rating explains. So if I come in here and I just square, what we're going to say is knowing the credit rating explains 99.37% of the variation in your credit limit. By just knowing your credit rating, I can explain about 99.37% of your credit limit. Okay, cool. That's great. Let's actually be able to put a relationship between those two things. Because what this tells me is if I know one, I basically know the other. Would you guys agree with that statement? 99.37%, correlation of 0.99. What that's telling me, if I know A, I also know B. Would you guys agree with that statement? All right, so let's check it out. Next, I'm going to do, let me zoom in just a little bit here. Created my chunk here. And basically all I'm saying, next I'm going to do a simple linear regression to quantify the relationship. All right. So all I'm going to do is I'm going to come down here and do M2. LM stands for linear model. I'm going to say limit is my response. Rating is my predictor, and data is credit. Okay. And then right off the bat, before I even run that code, I'm going to say summary M2 because I want to see what it does. I want to look at it all at once. So when I run this analysis, here's what it comes out. Limit is my response. Remember, this is what prints off summary M2. This is my summary table of the regression model. All right. Now, I want to take a minute. I want to make sure, again, I'm not going to try and rush through this example because there's some concepts here I want to make sure we understand because we're actually going to use this as we move forward, okay? Now, here's what I want you to think about. Here's what I want you to understand. Limit's my response, rating's my predictor. What I'm saying is if I know your credit rating from a credit bureau, automatically I know what your limit should be based on this model, right? That's what I'm trying to say. So basically, here's what we do. Remember where our eyes go. We're going to write down the equation this time too. My eyes go right here. What's the intercept? The intercept interprets as, well, if rating equals 0, here's your credit limit. Your credit limit is negative 542. Now, I don't know how credit works very well, but I'm pretty sure we shouldn't have negative credit limits, right? Like basically that interpretation is you're paying somebody at that point, right? Like you owe them money just to have it. So at that point, we're saying, look, that doesn't make sense. That's uninterpretable. But the other thing to remember is if we come up here and we look at the summary of credit, remember, there's no rating below 93, right? There's no rating below 93. So it doesn't make sense to even interpret it as when rating equals 0 because we never observed data there, right? So it's just something that helps the model. All right. What we do next is we come down here and we look at the slope for rating. Basically what it says, all right, it says on average, if I increase your credit rating by 1 point, your credit limit on average goes up $14. Now think about that. That's a pretty impactful statement, right? People always worried about what their credit score is, their credit rating is. If I can increase your credit rating by 1 point, your credit limit is going to go up $14.87 on average. That's a pretty impactful statement. You guys agree with that? All right. What's the other thing we look at? We look at this p-value right here. Now this plot, I can look at that plot and ask you guys, do you think that's a significant relationship between those two? Do you think credit limit and credit rating are related to one another? They better be, or we got a broken system, right? But now here's the question. Prove it. How do we prove it? We prove it with this p-value right here, right? What's that p-value? That p-value says, given that there is no relationship between credit limit and credit rating, what's the probability I would observe my data and a slope of 14.87 or something larger? It says that probability is less than 2 times 10 to the negative 16. What's that mean? There is a very, 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 very small chance that that would ever occur. It is almost improbable that it would occur. I've asked you to compare that number to what? 0.05, right? That number is smaller than 0.05. We reject the null hypothesis. What do we mean we reject the null hypothesis? It means that the slope coefficient for rating is non-zero. It means there is a relationship between those two things, right? So let's go to the next phase of this. Let's write this down. All right. How am I going to say this? Based on this analysis, the intercept is non-informative and is just a tuning parameter. The slope for rating is statistically significant when compared to P, let's say this, at a 0.05 significance level. 2 times 10 to the negative 6 less than 0.05. That's what I'm saying here, right? So we reject. So there is a relationship between credit limit and credit rating. Now I can't spell, so we're going to come in here and we're going to use the spell check feature, okay? Now we quantify it. Our model says that if we increase rating by 1 point, on average, the credit limit will increase by 14.87. We'll throw the dollar sign in there, okay? That's all we're saying. Our model can be written. Now, you can do this a few different ways. You can say limit is equal to negative 542.9. I'm going to round that to 3. Okay. 0.928. I'm going to round that to 0.93. Plus 14.87 times rating. Now, let me show you a little trick. It makes it pretty. If we put $2 signs around this, it writes it like an equation, okay? And it'll put it in the middle of the page. Now, see how I just finished my analysis and I finished my write-up? If I go in and I hit knit on this now, it's running all of this. And it's going to produce this HTML file for me, right? And so now I'm able to go through and I'm able to look at it. So when I look at this analysis, it's walking me through everything with the notation in here. Every time I finish a stage of this, I would normally hit knit. So when I finish this first chunk, I would hit knit to make sure it looks the way I want it to. When I hit the second one, I'm going to run that again, okay? Now, when we look at this, when we see this, when we go through this, this is the important part, okay? This is the important part. All right. What we're looking at here is we're looking to associate this plot, right, with that model. How do we do it? Plotting the model, we find the line, and then we'll add that in here in a second, because all I'm going to do is I'm going to come back, I'm going to create my plot. I'm going to say limit is the response, ratings the predictor, data equals credit, AB line, M2. And when I run that, how's the line fit the data, y'all? Pretty good, right? Ain't bad. You ain't going to see anything better in this class, I promise you. It all goes downhill from here. That's as good as fit as you're ever going to get on this, okay? Like we might as well close it up, call it shop, call it a year. But what are we saying about this? We find the line is representative of the trend shown in the plot. That's all you're going to say. Remember, when you're doing analysis, you're stating facts. All right? You're stating things to close to as factual as possible. It's about what you can prove. That's about as opinionated as I get when I'm writing an analysis. Because the line is representative is not something I can quantify. Would you guys agree with that? So again, you're giving an opinion slightly here, but you're saying, yeah, it does a pretty good job. Again, just to say there's a relationship between rating and credit, and basically say, look, on our average, here's the way we're setting credit limits. Based on a rating, we know you get a limit of about 14.87 increase for a one unit increase in rating. So a 1 point rating increase gets you about $14 extra on a limit. Now, your credit score jumps 10 points. What's that mean? It means you get about $148 extra on your limit. You guys with me on that? Now, watch how we prove that. If somebody's asking you to do a scenario analysis for them to say, look, what actually happens in these different things? Because that 14.87 thing doesn't make a whole lot of sense to me. What I'll do is I'll come up here and I'll look at my summary again. And I'll say, all right, what's the minimum or what's the median rating or what's the mean rating? We're actually going to use the median rating at 344. Okay. What I'll do is I'll say, look, for analysis, let's investigate what happens if credit ratings increase by 10 points. For simplicity, let's assume a person's credit rating is 344. All right. So all I'm going to do is I'm going to come down here and I'm going to say, look, I want to predict with M2 new data equals data.frame rating equals 340. Now look at this. What I'm doing is I'm giving it my M2. That's my model I created for credit limit against credit rating, right? I'm saying new data is data.frame rating equals 340. Notice I am saying it's a data frame and it has the same variable as the model in it. I'm going to set it to 344 because that's what I said I'm going to set it to. And I'm going to run the prediction. Now, I always want to look at these intervals. Here's my interval equals confidence. All right. Now what I want to do is do M2 new data equals data.frame rating equals 354. Interval equals confidence. Now, what am I doing here? All I'm doing is saying, what happens if the credit rating goes up by 10 points? We know based on our interpretation, that should go up by what? That number times 10. So it should go up about $148.71, right? So let's see if this matches us. 4721 minus 4752. $149. So look, the prediction at rating equals 344 is 457.2, so 4,572 and about 90 cents. At 354, it's 47.21, a difference with me rounding of about 149. So it fits that 147 target. But look at the differences and look at how tight these confidence intervals are. It says, look, your difference here on the average, because that's what a confidence interval is, right? It's the average, is about what? It goes from 45.54. So I'm 95% confident the average credit limit for somebody with a 344 rating is between 455.4, so $4,554 and $4,590. That's about a $40 swing, right? $36 swing across there. That ain't big. You guys agree with me? So we know that's the average. Let's change it up here. So I'm going to copy this one more time. I'm going to bring it down here. The confidence intervals have a difference of about $34. Excuse me, let's start with the predictions. The predicted values show with a 10-point rating increase, we have a $148 increase in credit limit. The confidence intervals show about a $36 range. All right, now, here's the next thing. I want to now look at the prediction intervals. Because the prediction intervals are going to come back and show me, and let me just run these together too. They're going to show me the same predicted value. They're going to show me the same value at fit. But watch the difference between the lower and upper. All right, it says, look, these are the mean intervals. This is the interval on the mean. So the average person, or on average, a person would have a credit rating or a credit limit between 4,554 and 4,590. Any person would have a credit limit between 4,213 and 4,931. All right. Or in the case of the 354 credit rating, we would have a limit between 4,362 and 5,080. Again, just looking at the difference here, about a $700 swing in your credit limit, right? For any person. Any person would show in about a $700 swing on credit limit. Both of those pieces of information are useful because what we're able to say is, look, I'm 95% confident in the way we've been doing this. We can set this range. Any person would fall in here. On average, what we're giving them is here, though. That's the difference in the explanation, remember, between prediction and confidence intervals. So what I've done now is come back and show them, look, somebody who has a 354 rating, which is 10 points above the median, right? Why did I select 344 and 354? Because medians, right? This is what most of the data, this is in the middle of my data, right? That 10-point increase, somebody could actually break a $5,000 credit limit, right? That's useful information for them based on the way they've been setting things. All right. If you come back up here and start mapping this back to your data, where'd my data go here? Where's my pretty picture? Here it is. 354, right? Puts you about right here. It's where the majority of your data lies. 50% of your data is below it. 50% of your data is above it as far as credit ratings go. Talks to me about what's happening right there in that range. Further you go out, we know the less confident we are because what? Data spreads out even more, right? So again, this is the way you're going to use prediction and confidence intervals, okay? We're going to come down here. We're going to say, look, based on the prediction intervals, we see about a $700 difference between lower and upper bounds. And in the case of the 354 rating, it is possible for a person to get a $5,000 credit limit. All right, I'm going to hit knit. Now notice one thing. When I hit knit, this changes, right? What that's doing is it's saving the document for you. You guys may be used to Microsoft Word where auto saves a thing. All right. That can be the case. But what it does, it shows me what the document now looks like. So I'm knitting multiple times throughout my analysis, right? What you're doing is you're checking your logic. You're making sure your numbers show back up right too. And we had a question in the chat. Why am I using the median and not the mean? Sam, I think that was from you, right? personal choice. You can throw whatever number you want in there. For me, I typically use medians or means because I'm talking about a scenario, right? One of the things you guys are going to figure out, especially as we get into these next sections, is these scenario analyses are important. Why are these scenario analyses are important? Because that allows people to touch and feel. We're going to start building some complex models starting now towards the rest of the class, okay? And we're not going to build the models today, but we're going to talk about and motivate them, all right? But as we get more and more complex, what we need to do is walk people through scenarios they understand. What's your average client look like? What's the average case for this? What's the median case for this? The reason I chose median is because it puts me in the middle of my data, right? And if we look at just a basic histogram of credit ratings, we talked about skewed, right? This is skewed. Everybody agree with me there? That's not bell-shaped or symmetric. It's got a right skew to it. Why is it right skew? It's got that right long tail, right? Median is going to be a better measure of center, okay? It may not be that much better, but it's still more principled, right? And so when somebody comes back and asks you, why did you choose 344? It's there. Now, what you guys would understand, and again, this is something you figure out if you do a data-driven project, so here's my plug for that, is when we're walking clients through this, what we're walking them through are the scenarios they care about. So when I sat down with Gino from Bravo, or I sat down with Brennan from West Banco, or I sit down with the other companies we work with, what I'm walking them through is like, okay, who do you care about in this analysis? Oh, we care about the person who has a credit rating of this and this and this. And everything they're saying there, I'm writing down. Oh, we care about a person who has about median mean credit rating. We care about somebody who's in the middle here. Like at the ends, we know that's a weird and funky place to be, but it's in the middle. Now I'm acting like I'm Brennan for a second, right? Because that's how he would explain it, almost to a T of the wording, I would bet. But you would have other people come in and I go, well, I don't really know. We haven't explored it. So what you're going to have to do is walk them through the cases. So what I would probably do for a client is I would come back here and I'd actually walk them through multiple credit ratings, walk them through their first quartile, their median, their third quartile, and say, look, how good is this model? How much variability is there? To kind of show them the different scenarios. Does that make sense to you? All you're doing, guys, is a scenario analysis with a predictive model, okay? We're just walking through different scenarios. Y'all with me there? Now, that talks to us about an internal evaluation of credit. Like, how are we setting policies with credit, which is always a good thing, right? It's always something you need to think about. But let's take it a step further. What we really care about is how much of a credit balance is someone carrying, right? From a credit card company, you make money off fees, you make money off interest, right? So what we actually care about is balance. Would you guys agree with that statement? So here's what I want to look at. I want to talk about two plots here. So set up some new R code here. I'm going to say, I want to plot here's my credit rating versus balance. Talk to me about what you see.
It looks really weird.
Why does it look weird, do you think? I mean, I agree with you. It doesn't look like a straight line.
It's
But why are you saying it looks weird?
because it's scattered.
It's always like, first thing to assume is this beautiful, pretty straight line we saw up here. That may be the last time in your life you see something like that, okay? Go ahead and work off that assumption for a minute. More than likely, what you're going to see is ugly like this. The thing you guys will learn about me is I'll always show you the pretty first to drive home the points. And then we actually got to go do this in real life, okay? So let's assess something for a minute. What I've always pushed you guys on, critical thinkers who solve problems, right? What do you think makes it look weird? Think about balances for a minute. Think about how people interact with credit. What we just said Credit card companies make money off fees. They make money off interest, right? What happens if you pay it off every month? You carrying a balance? Austin in the chat, so many things at zero credit. Bingo. That zero credit turns pretty nasty, doesn't it? That credit right there, for people who have these credit scores and these credit ratings that are low or that are on the lower end, seems like a lot of people aren't catching a balance, right? They're using it to pay it off. So imagine you just want the airline miles. You like to travel. You just want the airline miles. They caught you in the Atlanta airport. Those Delta guys, they'll get you every time. Told you can get 100,000 airline miles. You sign up for that credit card. You're not going to keep a balance. You're going to spend a little bit of money. You're going to pay it off, right? Now, let's change the question just a little bit. Let's look at individuals that carry a balance on credit cards and how it relates to rating and limit. So what I'm going to do is I'm going to create a data set. Credit 2. I'm going to load up library dplyr for a second. Why? Because I want to use those nice pipes we talked about earlier. What I'm going to do, I'm going to pipe credit 2. I'm going to say, that's just the credit data. And I want to filter all balances that are greater than 0. I only want positive balances. You guys with me on that? So credit 2 is just the credit data where I only have positive balances. I need to come down here. I need to change that to credit 2 on both of these. And for this part of the problem, all I'm going to operate on is this. Now, what do you see?
It's a little better than before.
Not as funky, right? Still funky, not as funky. Like there's levels of chaos, right? That is less chaos because we got rid of those small balances or those 0 balances, right? How did I justify doing that? I changed the question. I said, what I'm really looking at is the behavior of people who carry a balance, right? Given you carry a balance, that's what I want to study. Statements like that clean data for us. All right. Now, come hang out with me in 451. I'll show you how to deal with the zeros too. But for right now, let's look at this. Given someone carries a balance, here's the relationship. All right. Next. Now, I'm going to run this piece of code. And I'm going to zoom out just a little bit because I want to be able to move between the plots. This is balance and rating. This is balance and limit. A, let's play optometrist for a second, or B. Which one are you picking? Do you want to use their limit or their rating? Or should we try and use both? Austin says both. How many of you guys think both? How many of you guys think credit? How many of you guys think limit? Here's what I want you to think about with a model because we only have 3 minutes left. When we're making this decision, what we're trying to do is we're trying to build something. Think about it as team building. When you're building a team, right, you want to complement people's attributes. Would you guys agree with me there? When we build models, we think about what new information does a new variable bring that doesn't already exist. So assume I'm using your credit limit to talk about your balance. Let's do dollars to dollars. You guys with me on that? What new information would rating have that limit doesn't? Remember I told you we were going to rely on this analysis? If I know rating, or if I know your credit limit, I know a whole lot about your credit rating, don't I? Because if I know your credit rating, I can almost perfectly predict your credit limit. Would you guys agree with that? So when we look to build models, what we're looking for, and what we're going to spend all day Friday on, all day Monday on, and probably all day Wednesday on, going to be a full week of this, is how much useful information is in credit rating, giving credit limit is already in my model. How much does it add to the team in that case? You guys with me on that? So when we think about building models, what we're doing, I want you to think about building a team. What does it complement? What new skill did it bring? What new information did that variable bring? Y'all with me there? All right, we'll hit that on Friday. You guys have a great week. Stay safe, stay healthy. Yell if you need something. If you guys are still struggling with the RMDs, reach out. Please, please, please. I'm going to have Catherine post this as soon as class is over, okay? Actually sending her the email and hitting save right now. Chris, what's up?
I'm going to stick up with the class. I have some questions.
Yeah, that's fine.